This week, we will discuss analog audio. Understanding the basics of analog audio is an important first step to understanding digital audio. Analog audio recording, editing, and playback is at the core of what we do in the music industry. We will focus on the basics of analog audio in this week's content. We will define what analog audio means, the analog audio signal path, and the ways in which we utilize electric analog audio signal. We will understand the fundamental terminology associated with analog audio, as well as the hardware involved. Exploring the history and development of analog audio recording and editing techniques and how they apply to modern digital ones is an important way to understand how we use a DAW. The word analog describes an electrical audio signal whose electrons move in a way that models or is analogous to a physical sound in the acoustic realm. Because electrical signal is made up of electrons that continuously change in positive and negative charge, much like the air molecules around us or water molecules in water, because of this property, it is an excellent resource for us to create something that is a model of or analogous to the actual sounds in the world around us. Analog audio is electric. Since electricity flows in a continuously variable way using positive and negative electrons, it is a great model for acoustic sounds in the air around us. Just as acoustic sounds excite the air molecules to create positive and negative air pressure change, analog electrical audio signals also create positive and negative charge. It is important to remember that analog audio is not digital. Digital audio, or anything digital, is made up of ones and zeros, is encoded in some way to further abstract the real sound in the air around us. It is another level of abstraction and a realm unto itself. However, to get to the digital realm, we must pass through the analog realm. So it's important to understand analog audio signal before we go into the digital realm. If the piece of audio gear you are using utilizes a digital cable of any sort to send or receive signal, then it is a digital audio device. Understanding the analog audio signal path is extremely important. It allows us to see and visualize the different stages in which many audio signals or audio systems are arranged and put together. If we understand this flowchart and these signal types, we can troubleshoot most any audio setup. We will discuss each of these steps in turn, but you will have to remember the 4 boxes and the 3 signal types. This model helps us to visualize the proper gain stages, or stepping up a voltage, to boost the audio signal correctly. As audio engineers or users of any audio gear, we navigate gain staging frequently, and the proper way to energize a signal will result in either a successful or unsuccessful recording session. Some audio components combine parts of this model. As we step through the model, we can see the input transducer. The input transducer, which I will explain later, sends out a mic level signal that is in millivolts. Mic level signal then needs to go to a preamplifier, which will then step up that signal to line level signal. Line level signal is expressed in volts and is then sent to a power amplifier. The power amplifier then steps up to speaker level, which is in watts, to our output transducer. Powered studio monitors, which are speakers with an amplifier built in, combine 2 of these boxes together. A powered studio monitor is essentially a speaker with an amplifier built in, and you will know it is a powered monitor if it requires AC power. Guitar amplifiers also combine 2 boxes. They combine a preamplifier and a power amplifier section to properly boost guitar signal. However, all analog audio systems follow this general model to work correctly. First, we'll start with input transducers. A transducer is a device that converts. It converts from the acoustic realm to the analog electrical realm and vice versa. An excellent example of an input transducer is a microphone. A microphone converts sounds in the acoustic realm to the analog electrical realm. Other examples of input transducers are instrument pickups and phonograph cartridges. These devices also listen for sounds in the acoustic realm and convert them into electricity. A speaker is an example of an output transducer. Its job is to convert sounds in the analog electric realm into acoustic sound. These two devices, microphones and speakers, have a symbiotic relationship. The microphone converts acoustic sounds into electrical analog signal, and the speaker converts electric analog signal into acoustic sounds. There are many types of microphones at many different price points, but generally, in this class, we'll just discuss the two most common types of microphones, dynamic and condenser mics. Dynamic microphones, generally, are very common, durable, and inexpensive microphones. They're often used in live stage settings because of their durability. They consist of a magnet, a coil, and a diaphragm. The diaphragm inside the microphone responds to changes in air pressure and moves the coil around a magnet to create an electrical signal that is analogous to what the diaphragm is hearing in the space around it. Condenser microphones are slightly different. They are generally more expensive and use electrostatic energy and a capacitor. Because of this, they require phantom power from the preamp. Phantom power is used to power the microphone from the preamp and is traveled back through the XLR cable to the microphone. Condenser microphones come in many shapes, sizes, and price points. They are used mainly for recording purposes and in controlled live audio settings where accurate recreation of a sound is a priority. These two diagrams show two microphone types, the condenser microphone and the capacitor or condenser microphone. I believe I misspoke. That should be a dynamic microphone up here and a condenser or capacitor microphone down here. Note this triangle that shows you the tiny amplifier built in that needs to be powered with phantom power. A condenser microphone has a movable plate and a fixed plate. The movable plate responds to changes in air pressure and creates a sense of electrostatic or changes in electrostatic energy between the two plates that is sent to this amplifier. Condenser microphones generally do not work without phantom power applied. Microphones have a field pattern. A field pattern is a three-dimensional area around the diaphragm of a microphone. It shows the sensitivity area of the microphone. It is important to be aware of the field pattern of a microphone in order to use it correctly. The most common field pattern is the heart-shaped or cardioid pattern. Other mics are omnidirectional or bidirectional or other designs for specific uses. Note on the right here, we have a drawing of a field pattern for this microphone. Notice that it has a somewhat heart-shaped design. Speakers also have a field pattern or a throw or an area of outward activity around its diaphragm. Those are generally in a wedge shape. The more gain or energy applied to either transducer, the bigger their field patterns and throws become. When these two zones interact, we get feedback. Feedback is generally meant to be avoided, but sometimes it is caused for effect. This diagram shows the overlapping of two field patterns, the throw of the speaker and the field pattern of the microphone. When this occurs, we get feedback. Input transducers generate a very weak electrical signal. Microphones produce a signal called mic level or low Z signal. Mic signal needs to be amplified before it can go farther down the path. It needs to become a line level signal in order for it to move forward. The preamp has one job to bring a mic level signal to line level signal. The term low Z refers to the mic level signal being low impedance or low impedance. Mic level signal is typically carried with an XLR or external line return cable. These are XLR cables. You know that they have the three prongs and a locking connector. Guitars and synthesizers produce instrument level signal. Instrument level signal is like mic level signal but is high Z and stronger than mic level signal. However, neither mic or instrument level are as strong as line level signal. Instrument level signal is typically carried with a 1/4-inch tip sleeve cable or TS cable like this. Instrument cables are used to connect guitars and synthesizers to mixers and amps. Line level signal is a very common standard audio signal type that is found in most commercial devices and consumer devices. Computers, smartphones, CD players, and other AV equipment use line level output. Line level can be carried over an 1/8-inch TRS or aux cables, RCA cables, or even through XLR cables. We use a mixing board to accept mic, instrument, and line level signals, and we use mixers to amplify everything independently and then unify them into an output line level signal. It is an important tool in any audio system, as it allows you to manage multiple signal types. Mixing boards feature a preamp. The preamp is designed to accept mic level signal and boost it to line level signal. A gain knob at the preamp area, typically at the top, controls the amount of energy or input gain the preamp will provide to boost the signal. Sometimes it is appropriate to utilize a DI box. A DI or direct injection box will down-convert line or instrument level signals to mic level signal. This gives you the ability to send the signal to the preamp and control the gain at the mix position. This shows us the input from an electric guitar. Well, it should look like a guitar, but it looks like an acoustic one, but you get the idea. This goes into the input of our DI box as instrument level signal. The DI box then down converts it to mic level signal, which we can then send through an XLR cable to our preamp, to our mixer. Then our mixer will allow us to use the gain staging in our preamp to manage that signal correctly. Now that we've explored all the parts of an analog audio system, let's see how everything is connected together. If we refer back to the flowchart at the beginning of our slideshow, we can see all the components from the signal path: the input transducer, the preamp, the power amp, and the output transducer. We can see how some of these very common pieces of audio equipment combine these elements. Our mixer is a preamp, and it gives us line level out. Our powered monitors combine the power amp and the output transducer into a convenient piece of gear that we do not need to connect two different pieces to. We see here that our analog mixer allows us to send mic level signal through an XLR cable, a 1/4-inch cable with instrument level signal, or even an aux cable with line level signal.